Right, this is your revision video for Chapter 9 on expanding and factorizing. Now the first bit of work we did was to expand some simple brackets. So you should be okay with this and it shouldn't need too much explaining, but multiply what's inside the brackets by what's outside. This works in all cases. But our work actually advanced up to a point where we were looking at these kinds of problems, where what's outside the brackets could be negative and also involve unknowns, and you'd have to make sure you're more careful when you try to expand these. In this case, when multiplying what's inside the bracket by negative 3x, you have to start collecting terms differently and thinking about a little bit of index laws and how to simplify with algebra correctly. But the overall rule is to make sure you multiply what's inside the brackets by what's outside. The next part was to look at, say, expanding brackets, but also putting some simplifying in. So you may end up with a pair of brackets in an expression like this, where you then expand each of the brackets separately. Again, taking care to make sure that you are using the correct signs. So on the right is a negative outside the bracket, -2, so making sure you adjust the signs correctly inside. Then simplifying by collecting the like terms together, so you end up with a final answer like this. The next part of our work looked at making sure that you could factorize an expression, so that means taking an expression and writing it with brackets. As factorizing would suggest, you would have to find factors. So in this case, you would only look at the numbers 6 and 15, and that means that a 3 would have to be outside the brackets. Once you know what's outside the brackets, you then have to work out what needs to be inside, so it would expand back to give you what you had. Now this work advanced up to making sure that when you were factorizing, not only could a number be outside the brackets, but also a letter or an unknown. So in this case, because both terms contained x, you could factor out an x. So in this case, the answer would be a 3x outside the bracket, and then working out what needed to be inside so that it expands to bring you back to what you had. So always make sure you're putting the highest common factors outside, making sure you are putting the highest common factor for the number parts, but also making sure you are removing all of the letters possible and making sure they are outside. The next part of our work looked at what happened when you had to expand two brackets that are being multiplied together. The method I went through in lesson was a grid method where we write out the terms for each bracket in a small times table grid. So x add 4 and x minus 3 down the side and along the top. Then complete the little grid and take those results and put them in a line, so just sort of group them together, with the x squared term on the left, the number term on the right, and any terms containing x in the middle. Then simplify the middle terms to get your overall answer. When we did this in lesson, we did discuss how there was a quick way to get to the answer without drawing the grid. So try and see if you can remember how to do that by looking at this example. The next stage of our work looked at factorizing a quadratic expression, so taking this and writing it as a pair of brackets. To do this, you needed to look at both the number parts and ask yourself, well, what numbers would multiply together to create -14 but add together to create +5? If you start with the factors first, you narrow it down and realize the only two numbers that would work were 7 and -2. Once you figured these two numbers out, they were what went into your brackets. So you would need x plus 7 because the 7 was positive, and x minus 2. You could always check that you've got the right answer by expanding your brackets to see that it does bring you back to the original quadratic that you had. The next bit of work we looked at was the difference of two squares. And it's about remembering this rule and using it in certain situations. So you might have a pair of brackets like this, which you could expand normally. But if you can see that they match the brackets on the right, the a plus b, so the a and the b have been swapped for x and 4, you could actually get to an answer quite quickly and write it as x squared minus 4 squared without doing any extra work. You can get to a quick answer and then just simplify that a little bit. The other way is to start with something like you've got at the end. So we could start with y squared minus 81 and actually write that with brackets. We could factorize it. And we can factorize it quickly by realizing that 81 is 9 squared, so we could get y plus 9, y minus 9. So you will need to remember the rule at the top and be careful trying to spot whether or not it applies to the question. It's not going to work in every question. You have to make sure you've got two squares, two things which are squares, and that they are being subtracted. It doesn't work with adding two squares, it's only for the difference. Now the next thing we tried to look at when doing the difference of two squares was when we had something that looked like this, where the a has been replaced with an expression of x plus 4 and not just a letter on its own. Now this was more difficult to get your head around, but if you replace the a and the b on the right with x plus 4 for a and 5 for b, you'll have something that looks like this, which can be quite messy, but if you try and simplify that down a bit, in the left bracket the x plus 4 then plus 5 becomes x plus 9, and the right bracket will become x minus 1, giving you this as your final answer. Now I know that we did find this quite tricky when we did it in the lesson, so I don't expect all of you to be able to at this time answer this type of question correctly, but do bear it in mind how it worked. The final part of our chapter looked at factorizing an expression that looked like this, where it's still quadratic, but at the front, instead of just having x squared on its own, it's going to have a number, so it's 3x squared in this case. To do this we used a rather large diagram, which was something I saw on another YouTube video which I found worked. But you kind of had to do a number of things which didn't necessarily make a lot of sense to start with. You need to slot all the three parts from the original expression into these places on the grid. So the 10x goes at the bottom of the diagram on the left, and the 3x squared and the 8 went in opposite corners in the diagram on the right. Then in the top of the left grid you put whatever the first term of x squared multiplied by the last term of the expression would be multiplied together, commonly called the AC method in most videos, but if you multiply those two, that's what goes at the top. Now from here on the left you do a bit of working out to figure, well, what two terms would add together to give 10x but multiply together to give 24x squared. So that's a bit like what you've done before, and you will get 6x and 4x. These two answers you then slot in the diagram on the right, and from here you start looking at factors that you have in each of the rows and columns and putting those on the left and the bottom on those red lines. So starting from the bottom row, they have factors of 3x, they can both be divided by 3 and x. This then leads to, on the bottom row, having x and then 2, and in the top left corner you will have 4. These answers here then are what you put in your brackets, so the 3x and the 4 in one bracket and the x and 2 in another. And so you ended up with the final answer like this. Now that's a very quick rundown of how we did this, and we practiced more in lessons, and it was the most difficult part of our work. So it's not something I would again expect you all to be able to remember and do in the test. So some further advice: use the book for extra help, make sure you find some practice questions to have a go at. Use the Active Learn website, that can be very useful for you, and also make sure that you can answer the easier questions first. Don't spend ages on the most difficult problems. There's always some easier work that you could be getting your marks from, rather than spending ages focusing on the more difficult ones. Hope this has been helpful for you. Thanks.